Okay. We're focused. Here we go. All right, number 13 on pretest 2 says plot the following. So you got a piece of graph paper there, you can plot the following. Here we go. 5 150. All right, 5 150. So that's on the 150 line, out 5. So right there would be point A. On the 150-degree line, 5 circles out. There it is. Now the next one is in radians. Since my graph paper is in degrees, I probably want to think about negative pi over 3 in terms of degrees. So what would negative pi over 3 be? Negative 60. So negative 60 is right here, negative going down. And it's a radius of 3. So right here is point B. On the negative 60 line, remember negative angles go down. 3 circles out. Oh shoot, the next one's in radians too. All right, so let's see, 5 pi over 6. That would be 5 pi over 6.
180 divided by 30, so it'd be 150.
150, so it's 4 comma 150, so it's right here. It's on the 150 line just like the other one was, but it's only out 4 units instead of 5. And then D is a bit problematic because D has a negative radius, and I cannot plot, I mean, think about it. How are you going to plot a negative radius? You can't. So you've got to rethink that point. What does that point mean? 2 comma 30. So that point is getting plotted right here. On the 30 line, 2 circles out. Because when you change the sign on R, your angle changes 180 degrees. Right? You go to the opposite quadrant. So this one was negative 150. It was down here. Well, now it's over here in quadrant 1. 180 degrees different. Okay. Now I want you to get your calculators out. And you are going to graph these 2 equations. And then somebody's going to come up and put them on the board for me. Because on your test, this is what you're going to have to do. You're going to have to sketch them on the calculator and then reproduce the picture on the grid.
Does that have to be accurate?
Yeah. Yep. So go ahead, get it sketched. We're going to do both of them. So there's the first one. Bless you. Put the second one here. We're on pretest number 2. This is number 14.
Are we in polar or parametric?
I'm not going to answer that question. I want you to think about it. I want you to look at the equation.
Square grid.
I want you to look at the equation.
Hold on, bro. No, I didn't know. Polar or parametric? I'm in polar.
What are R and theta?
I forget what parametric is.
Those are your polar coordinates.
I'm in polar though, but I get
Like where else not gonna look like that? It's right, bro.
Well, then something happened. You didn't do something right. I will not be sitting next to you when you take your test. You've got to be able to problem solve. Change some things.
Yeah. Dude, I've never done this the whole time. They've never had the circles on. I can do one. Oh, this is the old rose.
3 rows, 5 units long.
What is this? It's a good fish.
Finley Ward?
Yeah.
Finley Ward.
Treyarch, whatever. I just did Treyarch. What? I didn't say anything.
Alright, when you got a picture, I want you to come up and put it up here for us.
What's your like mag? Like what's your one?
Alex, where's your calculator? Jack, you got a picture drawn? Well, come up and put it on the board. Which one you got? The first one or the second one? Both?
Yeah,
Awesome. You can do them both then.
Yeah, I did them both.
Mm-hmm.
Number 1, that one's a rose. And that was the second one. Lima bean.
Lima Sun.
Did I just say lima bean in the test?
No, you can say Lima sign. But that's a good point. Before we even started, you should have known what these equations were because we spent some time talking about that. You should know what these guys look like. All right, so Jack says that the first one was a 3-leaved rose.
Yeah.
So he's going to get quite a bit of the credit for this problem, but he's not going to get full credit. What is picky Mrs. Ford going to count off for when we look at this picture? First of all, I want to thank Jack because the rest of you sat back and did nothing.
I did it.
Jack stepped up, so thank you, Jack.
I wrote mine down.
Now we're going to pick you apart because we got a little bit of a mistake up here. What is it?
No points.
Those leaves need to be how long?
5 units.
5. So we need to make sure this guy is coming down to the 5. And these guys should not be going past the 5. Okay? Now, Jack, is it picky? Absolutely it's picky. But I'm going to be picky. So you know those leaves have to be 5. Okay? Everybody in the room knows they have to be 5. So make sure when you draw them, they're 5. I'm not going to get out my little ruler or my little thing and measure to make sure they're exactly positioned correctly. That's pretty close. He's got 3 of them about where they're supposed to be. I don't have an issue with that. It's how big they are. I have an issue with that, okay? Good. Now, what about this one? Well, this one's not going to get full credit either, because this one has a couple of things wrong with it. One is just a shape mistake. See this guy right here? He's actually going to come out a little bit, and this one is going to match it, right? Now, what else is wrong? Well, the interior loop is beautiful, but it's only one big. So the interior loop should be just one big. And see this over here? That's 5 units long, so that's going to stop right here at the 5. So that would get you full credit, okay? Now those aren't gonna be huge deductions because you obviously typed it in correctly and reproduced generally the right shape. But since I'm giving you points for this, you need to copy it accurately. My only other alternative is to have you physically plot the points, and that takes a long time. That takes too long to do, okay?
I understand how that one, you have to take each one 5 sides, but how would you know that?
You would know that on your calculator. Your calculator has a grid.
Oh.
And you can count the spaces on your calculator. Yeah. Your calculator has the accurate picture. All you have to do is reproduce it. All right, so we have completed pretest number 2. Okay. What I would like to do now is, tell me, did we do the brief recap? No, we did that quiz, didn't we? Yes. I have it marked. We did that quiz. So now we are going to do the next page, which is another quiz. So go find the quiz that we did before, which is on the back of the brief recap page. Right? We did that one already. Now go to the very next page and it's another quiz. So we are going to do the old quiz, which starts with the problem 3, -2 in the polar coordinates. Alright, so this is the paper we're starting with. Alright, so it says quiz at the top, and the first problem is 3, -2. Alright, so here we go. We're going to change into polar coordinates. Now we've already taken a quiz or done a quiz exactly like this. So we should be able to get through this pretty easily. How do I find r and theta? I'm going to draw a picture of it. So boys, we paying attention? Okay. R will be 313. This is theta. This is going to be a mistake that some of you make because you're not paying attention. This is theta. So I'm going to find this one by second tangenting 2/3, which is 33.69. But theta is not 33.69. Theta is 326.31, because whenever you're writing theta, you are writing it in standard position, which means all the way around. Number 2 is exactly the same thing. I want polar coordinates for this number. So I know the radius is √5. And again, I'll find this angle right here by second tangenting 1/2. So 26.57. But this is theta. So 153.43. Is that right? Now, that is a beautiful answer. But, did you read the directions? R has to be negative. Okay? No problem. Does not impact the way I do the problem. All it does is make R negative and change the angle by how much? 180. So that would be 333.43. Done. Number 3, I'm going to write it in shorthand notation. Okay? It's written out in longhand, which those of you that did your homework know most of the problems in the book were written out in longhand, not an issue, not confused by it. I need to change this into rectangular form. What does that mean? X plus yi, that's where we're headed. We want x plus yi. How in the world am I going to find x and y? X equals 2 cosine 110. Y equals 2 sine 110. 110 is not special, so I don't have a choice. I have to do it. So I got negative 0.68 and 1.88. So there is my complex form, rectangular form, standard form, Cartesian form, whatever form you want to call that. There it is. X plus yi. Now number 4 is really the same question. What do I mean by that?
It's the same thing.
I'm still finding x and y. Gonna do it exactly the same way. The only difference is because that's an ordered pair, when I write my answer, I will write it as an ordered pair. Instead of doing the x plus yi thing, it'll just be x comma y. So, what will x be? 4 cosine 170. So negative 3.94. And for sine 170, 0.69. And there we go, we're done.
That's you. By March 9th.
Okay? Alright, rewrite in polar form. Alright, now what does that mean?
Work backwards.
That means find r and theta. I am shooting for polar form. So how do I find r and theta? I'll draw a picture of it. All right, so what's r? 41. Now be careful, this is another one of those. This is theta. But we're gonna find this first by second tangenting 5/4. So this is 51.34. That is not theta though. Theta will be 180 minus that. What? 128.66. Now we're going to write as a Cartesian equation. Okay, so what does that mean? I need x's and y's. So this is the kind that's a little bit trickier. I gave you a big hint. What did I tell you? Anybody remember about?
Replace the cosine with x over r.
Change your function. Whatever your function is, change it. So we happen to have cosine. What's cosine? X over r. So r squared equals 2x if I multiply the r over. And r squared is x squared plus y squared. Those of you that are still in la-la land, over x up y, this is r. Pythagorean theorem, r squared is the same as x squared plus y squared. And now all my variables are x's and y's. Number 7 is the opposite of that. These are the easy ones. No work involved with these guys.
Just change
What do we do?
Change the x's and y's.
Change
to
the x's and y's to r cosine and r sine. Here we go. Every x became an r cosine, every y became
That's all you have to do, right?
an r sine. That's all you have to do. There's nothing else to do with this one. Nothing else to do with it.
This is like the test.
And then we're going to do some multiplication, division, conjugate, and magnitude. Here we go. So you've been given a couple of numbers in polar form, and you're going to multiply them together. What's the rule for multiplication? Multiply the r's, so that would be 15, and add the angles, so that would be 250. There's the answer. Now we got a division. What's the rule for division? You divide the r's, so it's z1 over z2, so it'd be 3/5. And then what? Divide the r's and subtract negative 90. Whoopsie. What do we know about negative arguments? Can't have them. So we need a positive equivalent of negative 90. 270. So there's our final answer. All right, how do we find the conjugate?
Same R.
Same R, so since it's z sub 1, it'll be 3. And then what? The angle becomes negative, because you're going the other way. But of course, we don't want that. So we always got to fix the conjugate, because it will always be negative. So what is that, 280? And that would be my final answer. With the conjugate, r stays the same, and theta changes sign, right? All right, and what does this mean? The magnitude of the number, and that's just r. That's how long it is when you graph it. That would just be 3. Okay, now there are a couple things on the test that aren't on this. Okay, this is most of it, but there's a couple things not here. So I'm going to throw a couple more problems up here.
So this test is going to be like super big, is it?
Huh?
It's not going to be like a super big test?
No, I mean, it shouldn't take you that long to do.
It's just like a bunch of examples of this stuff.
It's a test though, it's 100 points.
That's huge. So fun.
Okay, so let's suppose we want to find the exact rectangular form of negative root 2 plus root 2i to the 9th power. All right, so here we go. Deep breath. We're raising it to the 9th power. So what's the first thing we have to do? We got to change it into polar form, CIS form, which means we need to draw a picture of it.
So R is going to be 4.
No, R is not 4.
No, B2.
It'd be 2. R is 2.
Plus 45.
It's the square root of 4. Right? You square that, you get 2. If you square that, you get 2. If you add them up, you get 4. And the square root of 4 is 2. So it's 2 CIS. All right, what's this?
45.
45. So this is 135. And that's the number that you are going to raise to the 9th power. Okay, so how does that work? How do we raise to the 9th power?
So we put 2 and then root 9.
No, not
You do.
root 9, 2 to the 9th.
Yeah,
Yeah,
2 to
Yeah.
the 9.
So we take 2 to the 9th, and then we take 135 times 9. Alright, so 2 to the 9th, 512.
Yeah.
And 135 times 9 is going to be a big
12,
number.
15.
Okay, now 1215 is just a little bit too big. So let's shrink it down. So what's it going to go down to? 512 CI is what?
Oh, wait, no.
Is it go back to 135?
Yeah, 135.
Now, what's that?
That's the
That's my polar form, right?
Yeah.
If you needed the polar form, if it said answer in polar form, you would be done. That's it. But it didn't. It said answer in exact rectangular form, which means you need to find X and Y, right?
Yeah.
And exact means not on your calculator. So X equals 512 cosine 135,
Yeah.
and Y equals 512 sine 135. 135 is special. If I'm asking you to do it without a calculator, it has to be special. What's the cosine? Negative 1 over root 2, or negative root 2 over 2, which will be negative 256 root 2, if I cancel. The sine is positive root 2 over 2, or 256 root 2. So what's the answer? X plus YI. Your answer is in rectangular form, X plus YI. Alright, let me think of another one that's on the test that's not covered on that sheet. Is it an emergency? Alright, here's another one. Find the polar form of the 5th root of, let's say, I'm not going to rig this one. I'm going to make this one not rigged, so we need a calculator. 2 minus 3i. Find the polar form of the 5th root of 2 minus 3i. Alright, so what's going on?
What would be 2 minus 3i?
2 minus 3i to the what power?
1 over 5.
1 over 5. Now, as soon as I do that, or as soon as I read the problem, I know I'm going to have more than one answer, right? That problem only had one answer because it was to the 9th. The only time we have more than one answer is when we have fractional exponents. Okay. Alright, so what do I do?
Put it CIS.
I need R and theta.
Thank you.
This is going to require a calculator. Not for R. R is,
Root 14.
root what?
13.
13? So I have root 13. Now I'll use my calculator. I feel like I've already found that angle once today, but here we go. We'll do it again. 56.31. But no. Don't use 56.31. Use 303.69. And that's the number that you are going to raise to the 1/5 power. Okay? So here we go. We're going to do exactly what we did over there. We're going to take root 13 to the 1/5, and we're going to take 303.69 times a fifth. Now, this is not okay.
13 times 1/2.
You can either write it as a radical, or you can write it with an exponent, but don't do both. This is both. See that? So my preference is, this is 13 to the 1/2, then to the 1/5. So it's 13 to the 1/10, which is fine. I like to write it as the 10th root of 13. That's my personal preference. This is fine. You're going to write 13 to the 1/10. I'm going to write the 10th root of 13. And then I need to do 303.69 divided by 5, 60.74. Got a little round off in there, but oh well, it can't be helped. Are you all right with that? All right, now we said that that's our first answer. All good. We said there were going to be 5 of them. They're all the same length, so they all have exactly the same radius. But now I need to find those angles. And how am I going to find the angles?
360 divided by 5, and then you add that number 60%.
So I'm going to be adding 72, because 72 is a fifth of 360. And if these are all spread out evenly, they're 72 degrees apart. So I'm going to add 72. Did you notice I got a little carried away? It's all right. What happens? That guy right there's too big, isn't he? So when I shrink him down to make him acceptable, I end up right back where I started. So here are my 5 answers right here. There they are. Okay? One more I can think of that wasn't on that practice quiz, and then I promise I will shut up. I want you to sketch. Alright, here we go. I want somebody to sketch this, and then I want it up here on the board.
Can I do it?
Oh yeah, you're sketching it on a calculator. All your sketching is done on the calculator. Alright, hurry up, get it sketched, and then you're going to come up and put it up here. Abby, I don't know what you're talking about, but I want to see those fingers punching those buttons on that calculator.
I did that last time.
Make whatever adjustments you need to make, if you need to make any, and then come up and put it up here on the board. Somebody to come up and grab it. And keep in mind what we learned from Jack.
Why is mine a circle?
Probably because you're doing something wrong.
Didn't put the 6.
It's called operator error.
I'm not very smart.
I need a volunteer to put it up on the board.
Wait, what's with the window?
I'm not telling you what the window should be. Figure it out. Here comes, look at Stu. Coming up.
I got it. As soon as mine's done graphing.
I can do redemption. Wait, give me a
I
second.
do.
You need a.
Steve, I thought you were putting the problem on the board.
I didn't get a tissue.
Well, put the problem on the board on your way by then.
He took it the other way.
He'll be back.
I'll
Or
do it.
Keyshawn's gonna bail him
I
out.
was gonna do it. I actually wasn't gonna do Wait, I don't know how to do it.
Please release.
Color? Just there, they just sign someone. Like this is
I did it again. Dang it.
I with the old.
He ain't playing in the league again. No one's gonna come up.
Look at it.
Hey, Marty.
While we're waiting for this to come up here on the board,
Oh no.
does anyone
I love being this high.
have a problem type that we need to practice before you take your test? This is the last time I'm gonna see you
We're gonna have to
until you
like.
take your test.
Learn day? Well, you have to like get one of those and like save it.
You may indeed have to do that because we've talked about that. What are the 4 classical curves?
Sun, lemniscate, spiral, and rose.
Spiral,
Lemniscate.
lemniscate,
Rose.
and the rose. And we have talked about your ability to identify each of those. How do you know a lima sign when you see it?
The absolute value.
It has an add or a subtract in it, right? How do you know a lemniscate when you see it? It has an R squared. How do you know a spiral when you see one? It just has an R and a theta. There's no sine or cosine in it, or tan, there's nothing in it, just a theta and an R. So in terms of me asking that kind of question, I would feel perfectly comfortable giving you this and saying, what curve is that? And you would say that's a lemniscate because it has an R squared. I would also, because we've already quizzed over it, feel perfectly comfortable giving you something like this and saying, how many leaves does it have? 8. So yes, there are things we've talked about that you need to know. Now, in terms of getting super picky and specific about these weird variations, no. But the basic 4 curves, you need to know their names, and you need to know how to distinguish between their equations. Okay? Now, let's take a look at this one.
Yeah, but some of R squared.
This is a lima sign,
Some have a plus in it.
and how high does this thing go? It goes up to 10, so I want to make sure we're at 10. I'm not sure. On the test, you probably aren't going to have room to extend your graph the way he did. And it's fine to do that, just like you can extend a Cartesian graph. It's perfectly okay to do that. But I don't think you're going to have room to do it. So what's your alternative? If the picture gets too big, you change your scale. So instead of having each circle be 1, maybe each circle could be 2 or 10, depending on the size of the figure. Okay?
Why did you
John, did you graph it on your calculator?
Yeah.
Count the hash marks. That's how you tell. Everything you need is on that calculator. You just have to pay attention to it. Okay? All right. So I think between the problems I've just done and the quiz we just took, we've reviewed everything again. Can you think of anything that we need to review still?
Well, you have the test, so you know better than us.
Well, you have a test.
We can do
Because I've given you 2 pre-tests, right?
Let's do pretest 1.
All right, here's where you have half an hour. I want you to work on pre-test 1. you're gonna turn in pretest 1 and 2 Monday. 2 is done, finished. So now you have the rest of the period to help each other figure out 1 tomorrow. Everybody else is tomorrow.
Pretest 1
Monday, Monday night.